So for our project, we wanted to improve upon the original device, the original microgravity device that is in the lab. The key areas that we were able to improve on were: one, we went from imaging one batch of cells to 3 at a time. We replaced the covers for the cells from steel to 3D printed materials so that it doesn't rust. We also made the process of replacing these channels much easier so that you can spend less time with the cells under normal gravity conditions. Furthermore, we placed the entire device within an acrylic casing with a heater inside, so now you can run the experiments outside of an incubator. Another improvement that we implemented was we now use a Raspberry Pi computer to control the device, and with this we were able to create a user interface that allows the user to pick the rotation speed of the motor, which you will see later. Lastly, the device was originally made for $2,000, or purchased for $2,000 rather, and with the materials that we used in our device, we were able to get the cost down to about $270. Alright, so this is the device that we designed to simulate microgravity. As Q will explain later, you will load cells into one of these slides and then put the slide right into this channel. And then use these to secure it in place. Then you're going to cover up the device with acrylic sides, which lets the device be heated, this heater, so you don't need to put it into an incubator. And then using this interface, you can select the speed that you want it to rotate at, for example 3 RPM, and the device will begin to rotate.
So prepare 3 50mm Falcon tube, one for media, one for PVS, and one for 70% alcohol. We are going to aliquot PVS media for sterile, to keep it sterile. And we are going to use these 26 gauge needle, 1 milliliter syringe to wash our slide first with ethanol. So prepare a liquid waste box and just inject the syringe in one end of the slide, and then the ethanol will go through the channel and it will drip into the liquid waste. And you just repeat this step twice to make sure that everything is washed away with ethanol. And then switch the syringe to a new one And now we are going to wash the slide with PBS because ethanol is toxic to the cells. And washing the slide with PBS will remove the remaining ethanol in the slide. We are gonna wash 3 times with PBS. And then you switch to another syringe. Now we can fill up the slide with the fresh media. And we are going to use this MDA breast cancer cell that's been pre-suspended using trypsin. And we are going to inject the cells as if we are washing the slide.
Okay, so to test whether our PDMS channels in the 3D printed slides were suitable for cell growth, we injected some cells into these channels and watched them grow over time. So in these images, on the top we have 10 times magnification images, and on the bottom we have 20 times magnification images, and it shows the time lapse from at 6 hours after injection, 12 hours after injection, and then 18 hours. And you can see that the cells are growing, in fact, and it is possible to image through the PDMS. So this means that we will be able to place these into the microgravity simulator and then be able to image them later on.